So I think today the topic is about missing values, right? Dealing with missing value in data set. And missing values are some kind of noise that, noise and still introduced in our data. And we need to deal with them, either, remove them or, interpolate them or whatsoever, just to make sure that they don't cause any problem. So they are very important, for example, in machine learning. When your data has some missing values, you need to do some ways, to make sure you correct the data so that your model can learn. I think we're gonna use three ways approaches. Explicit missing value, number one. Then we go and see implicit missing values, and then we go factors and empty growth. So in the explicit missing value, you will see, yes, of course, from your data there is some missing value, and you deal with it. In implicit, you will not even notice, like, all those that you have input some missing value. So you need to work some ways to find out. So trying to start with the first one, which is explicit. So we can see here, this is a data set. We have missing value, right? Which is any. Now, how can you deal with this missing value? One way is to say, okay, deal with all this one, carry the last one to the next. So here we have, Derek, just replace this with Derek, or here, or for example, here 10, you can replace with NA, you replace then with 10. That's what this means. So here we can see fill everything. So this function, we all know it will fill everything here with fill. So when we run this, so here you can see whether you have missing, it tells you when you have this thing. But by default, this function fill is actually using something. It's using, so this fill, it does have many, arguments. So if we look at fill here, we can see basically it has a lot of stuff, which is, okay. Oh no. Okay. Let me see. Fill, no, not this guy. Fill. Okay, fill missing value. Okay. So you can see it has like down, down, up, off, the direction, down. But by default is, I think, currently either down. Default is down. So you can see here, like, it will just replace this one here, down with this. So you can basically specify the direction. You can see when I say down, it give us the something. So you can specify how you want to do the filling, right? Whether you want to do the up or down, up, whatsoever. So this is, I think this down, up, that is down, up means the first down and then up. The first down and then up. So they are just, it depends on how you want to replace the missing values. Yeah, so that's the first way to approach this one. One way, I think, which is not, explained in machine learning community, I think we use to, finding the mean. For example, if you have text, numeric value here, you can find the mean of the data set and replace with the mean, or you can find the median and replace with the mean if you have like, continuous value, something like this. But here, what it's doing is just filling with, the neighbors in it. It is not doing any kind of statistical, stuff. Yep. Anyone wants to add something here? Ahmad?
No, no thanks.
Yeah,
Okay.
no, I think there are also some like imputation techniques where you could
Exactly
use some interpolations and fill the missing values as well.
Yeah, so yeah, in machine learning community, I think there is this kind of imputation, like, deductive imputation, or even regression imputation. You can even use regression, to fill in some values, right? So all those things can be done. But I think in this book, they don't actually, look deep into those kind of, they just look at it, I think, in the angle of data analyst, but they didn't go further, like, to do that kind of imputation here.
Yeah.
Yeah, so here they talk about fixed values. So here what this means is that so here we can see we have NA obviously here from this. So what they are saying here, I think, if, for example, here, sometimes missing value represents some fixed non-value, mostly 0. So you can use the flag coalesce to replace them. So what this means is that here we can see we have 1, 4, 5, this, and NA. So we can use coalesce to replace any NA with the values we want. So for example, if we want 1 or 2 or whatever, so we can use this function. But another thing here is some, typically in previous day, if people want to put missing values, which I think is no longer in existence, they use like negative large number and like negative 99 or negative 100. So you can use this function as well. NA if this, is this value. So if it is this value, then you change it to NA, and then from there you can take it forward to, do whatsoever you do. So that's this. But there is also none, which is, not a number. Is more or less like, NA as well. But this is what happen is when we do, we all know mathematical operation that, doesn't give us an answer. For example, 0 by 0, or this by 0 multiplied by infinite, it will give you none. So in this case, if we have this kind of, operations like none, so we can typically use, this either this way or this way to replace to the required value we want. So what they are trying to show us here is that instead, for example, normally somebody can see only this NA, but you can also see something like none, and then you can typically consider it as a missing value. So that's something that you will be able to see missingness in your value, in your data set, which is the term as, explicit, missing value. Then from there, they started discussing, even though today chapter is very small, it doesn't take, it will not take, I think, 30 minutes to finish it. Then they move on to the implicit missing value. So anyone wants to add something from moving into explicit to implicit?
No, I think it's good.
Okay,
Yeah,
right. So the implicit missing value, here we can see, oh no, let me see this. Okay, so here we can see here we have a data set. We can see here is we have years here and the quarter and the price, right? So we can see here like the first quarter, second quarter, third quarter, fourth quarter, right? And what happened is that in the 2020, 2020, 2020, all first and second after fourth. But in 2021, the first quarter is missing, right? There is no one. It only starts from 2, 3, 4. This means that this is implicit missing value. Why? Because nothing has been shown here as missingness. There is no missingness. It shows you here. Now, do you want to talk? There is no missingness here in this data in this column now, but obviously there is missingness in the second quarter, right? So this is what this is talking about. So if we look at this guy, how can we do this? So by default, making data longer preserve explicit missing value, but if they are structurally missing value that only exist because the data is not tidy, you can drop them. So let's look at how to deal with this. So they have a function called complete. Let's look at what this happens. So we take the same data stocks here, and now we run this complete. We give it these two columns, the year and this. Now when we run this guy, okay, so you can see here, this complete function, what it does is, you need to give it as argument what you think should exist in the data set. That means even if there is missingness, this function complete will complete them. So here we impute, you can see 2 columns because, price can be missing, but the year and the quarter should not be missing, right? So what you need to do is to give this, call the data frame, and now call this function complete with columns that must be there. There are no missingness because year or $4, of course, we should have a year and so you can see 1, 2, 3, 4, and you can see like it added 1, 2021, you can see that, but we have 1, 2, 3, 4 now, unlike before where we only have 1, 2, 3, 4, but here there is no one. So this function created this one, and you can see it automatically create the missing value here.
So I think if the column is monotonically increasing, like
exactly, exactly,
yeah,
exactly,
and you know that it should be monotonically increasing, and it just combine, and here he used like combination of 2 columns. So because if after 4 quarters it should be increased by 1, as a year should be increased by 1, and then begin again from 1 again. So he knows if we pass it for if we pass for it 2 columns that really monotonically increasing, and he sees this from data, then he replace just the missing value with duplication and add the missing value as a new row. That's what he's doing. So it's really interesting. I didn't think of any functions that could do this.
Yeah. This is really interesting. I didn't even think about it. Yeah, this is actually interesting. How it was. There is nothing like, somebody may think, okay, this is, working like predicting, but it's not actually predicting. But my question, what I think here is this, what about if we have a single column? Because even a single column, if it is monotonically, I think if we remove, okay, let's remove this column. Let's put this one. Let's see what will happen. I think it will, let's see what will happen. 1, 2, 3. Okay, look at what happened.
So it should be like 2 monotonically increasing, or something like they should be complement each other, the 2 columns. So the year should be like 2022 to 2020. Then after 4 quarters, it understands that it should be begin a new year. So if we just pass it as a quarter, it doesn't recognize it by a year. So it said that how I want to categorize the quarter. So it doesn't understand how it should be like two different columns. The combination of two columns, so like the rows in each one of them should be unique for its insertion. Like you see here, 2020 is first quarter is different. Is very like it doesn't like duplicated, so it's unique. So that's what I understand from it. Should be like the 2 column monotonically increasing and unique. The combined 2 column should be unique. That's what I understand. But I think there's more for argument. Their argument should be like explained. Right?
Yeah. I'm looking still.
He said here like combination. I see here combination.
Yeah,
I'm
still
the
looking.
word combination. Yes, combination of data. Yes.
Yeah.
So he checks the combination, and if something missing, he just add it. So I think they like. Yeah. I think I understand it. It's just a combination between multiple unique columns. Yeah, this is what he said, to find all unique combinations of X and Y and Z. This is how he's doing it. So yeah.
So let's look at this example. So look at this example. We have group 1212, item ID 12, 2, 3, item name A, B, A, A, B, B. Then we have value 1, 2, this, and value this. So here they try to complete, and now they take 3 arguments here. We have group, we have item ID, we have item name. Now, so you can see here, let's see here is 1, 2, 1, 2. All right, here is 1, 2, 2, 2, A, B. Now, so here you can see they are taking the combination of all. So here we have how many? 1, 2, 3, 4. How many are we going to have? I think we are going to have, how many items do we have? 1, 2, 3. Then we're going to have 12 rows, right? Combination. Yeah. So you can see we have 12 combinations of each and every possible case. So, yes. Yeah, and here
I think
we have
it depends on the uniqueness of the column. So you have to be unique. The combination should be unique. That's what I understand from it. The combination should be unique.
Yeah,
so
exactly.
If you see the first row, it's unique. It doesn't replicate. It's not replicated or duplicated anywhere. That's how
so I think so I think the first one, the previous one here where I put 1, it cannot do any complete with one column, one variable, because it is only one that it is not competing with another one. So if you have like 2, but yeah, okay, I see.
Again, you should think of it as a combination of 2 or more columns.
Yeah.
That every row should be unique.
Exactly. Yeah, because look at this one here. So for example, let me show us here this example, the first one, this one. Okay. Oh no, not this one. Before the complete one. Oh, okay. This is yeah. Okay. Yeah. Right. Oh no, this one. Yes. I'm talking about this one. Okay. This is the original, column, right? This is the original. And we have the missingness. How many rows do we have? 1, 2, 3, 4, 5, 6, 7, right? And we have 2 columns. So we have 2 columns, right? So you can see with 2 columns, and we have
we're missing the one from
we are missing. Yeah, but how can I see why do we miss the one? I'm trying to figure out, the missing the one because we have 7. Because there is
I think of it like if you multiply if you get the combination of these 2 rows, there is 1 row that doesn't exist in the value.
Yeah, exactly.
That's how we added.
Yeah. Okay, makes sense. Okay. I think I understand it more with the discussion now. Yeah, I understand it more with this discussion again. Right. So, okay. All right. Abdullah, are you around?
Yeah. I'm following.
Yeah. Okay. All right. So let's move on. No, I didn't ask you to run. Okay, let's go to the video. No. All right. Okay, we have seen now what complete does is it try to complete the store, and then another one they talk about is join. So this is something natural in the sense that, for example, we haven't discussed join, but I believe we all know join, where you have for example, one data frame and another one, you can join them. But the anti-join, I think the next chapter is discussing all this stuff. So then at the anti-join, try to find out what is here, that is here but not here. That is anti-join. So in this case, we can use this idea to find, missingness. So let's look at an example. If we, oh no. Why is this? Okay.
So
No.
it's like the inner join, but reverse, not
Oh
matching.
yeah, yeah. So the anti-join, inner join will put everything like, you know, what is
Match.
in X and in what is not inner join is not match, right? Inner join, no, it will put everything together. What is in X and Y, it will match them together. I think that's what is inner join, right?
It's yeah, it gathered the matched
Yes, yeah,
the match between two tables or two data sets. So
yes,
here I that's why I'm strand of anti-joint. It's just not match.
yes,
in
exactly,
all-
exactly,
yeah.
exactly, exactly. Not much. What is, yeah, not much. What is not inside here? Not much in a simpler way. Yeah, not much. Something that is not in the two. So let's look at this data set. So here we can see this flight data set. And what we are interested to look at here is,
sorry, I don't know what I'm lost, but I think you've discussed pivoting.
You say what?
Like pivoting, because I think in the book they also mentioned something like pivoting.
Oh, we missed. Oh,
Yeah.
okay, I skip it. Oh, it's here.
It seems like you skip it, yeah.
Oh yeah, okay. I didn't know I skipped it.
Yeah.
Okay. So pivoting is, one way also to, make our data to allow us to see if we have missingness. So let's look at this. So we can see here our data set. We have in 2020, we have 2021, and the year here they put it in 1, 2, 3, 4, and but this actually, oh no,
Yeah, I think
oh,
it's saying
oh,
that,
the same data that, oh, the same data. Oh, okay, the same
yeah,
data.
yeah, I think it's
Yeah,
just saying that the pivoting
yeah,
is
yeah,
yeah.
exactly. So here they are just using pivot weather. I think we used this pivot weather before, right? So pivot weather, it takes something that is long and now changes to more wider. So what they are saying is that using pivot weather, taking your data will inevitably shows you like, there's something missing, because here we have 1. So you can see in 2020, we have 1, this is the value, but in 2021 is NA from our data set, right? From the data set, because here is missing. So yeah, so what they are saying is, pivoting, but I don't think this is useful, trying for you to find missing value to just pivot your data to wider to see it. What do you think?
Yeah. So I think what I get from the pivot to the, it's like what he's talking about, the pivoting is like it's a way that can sort of introduce, is it missingness in the data sort of.
Yeah, because like what we are trying to see here is that some situation your data is explicit, implicit. I mean, the missingness is not obvious, right? So
Yes.
the missingness is not obvious. So given this data, one may not, know, there is, missing data. So it's implicit. So one way is to, use this pivoting to show it. So this is what shows us, there is this. But
Yeah.
this complete is used to, to complete the missingness, right?
Yeah.
So
Yeah.
yeah.
Yeah. So
Okay.
thanks for that.
So the join, yeah. So as Ahmad said, the join, anti-join is opposite of inner join. That shows you, what is not common in these two data from overseer. But let's look at an example here. So here we have our flight data set, we already know. And if we look at this data set, we can see, we have a column called destination here. You can see destination, right? So this is a single data frame, right? Flight data set. Now, let me flight data set here. Okay, so what I do here is like I find a distinct, distinct column, distinct rows, or yeah, distinct
Destination,
rows.
I think. Right. Destination.
Distinct rows, a distinct destination, sorry, distinct destination, and this where we have like, oh, we have 105 destination, but because you can see the data set, I think we have this number. So we find the distinct here, and we rename the column to FA. So you can see here, this is FA, right? And we have this now. So you can see here, we have this. Now, let's look at another data set, which is airports. So you can see this is airport data, and it already have the destination. You can see FA. So the reason why we changed this guy to FA, because we want to do comparison between these two data frame. So you can see here, this airport data, we have FA, right? So we have two data frame now. Now we can do this flight, combine this distinct, which I already shows it. So it filtered the distinct. Now we can use anti-join. So anti-join will now find out what is here, not here. Can you see that? So this shows the airport that is missing in, destination. So you can see here we have this, and this. So this means that, this, what is happening with my, do you, Ahmad or Abdul, do you know why I asked this question, like in visual markdown, this is not well, I don't know why this is not well represented. Do you know why? Like this one is not showing.
No, not really. I don't.
Okay. All right. Because I like the visual, but it's misbehaving sometimes. Okay, so we can see here
the concept of the anti-join, it's clear.
Yeah.
You
explain so
it quite clear.
Okay, so you can see now here we have anti-join. So this data set, this destination, they are not available. So you can see here it shows some kind of what is this? I don't know what is happening with my
Maybe you could shift to the compiled tab.
Okay, so yeah. So in any case, we can see here anti-join allow us to see, but I don't even think of it like in which way somebody Ahmad, are you talking? You want to talk, Ahmad?
No.
Okay.
I'm with you.
Okay. So, but I don't think I think Ahmad, maybe your mic is doing. Yeah, your mic maybe.
Okay.
Is it Ahmad?
I will just mute.
Okay. Yeah, your mic is doing some stuff. So I don't practically. I think okay. We have now seen like how we can use antigen, right, to find what is here. But is this also a way to find missingness? I don't know. Like how can I just try, find if I have two data frame? Yeah, I think it's one way, but I think
I think this is because if you have the already a full table
data. Yes.
and you want to check that if this if any other data set that have the same column exist, those the particular value of one table is like all of them are exist in the second or not. So it's
Exactly.
you check the missingness of values, not the missingness in terms like NA. It's not NA. It's just
yeah. I get you. Yes, Ahmad. That makes sense.
Yeah. I think it just like Ahmad mentioned, it's like when you are trying to, let's say, merge or append to data sets.
Exactly.
So maybe you might be concerned with the unique identifier and see whether the all the values in this unique identifiers for the two data sets you want to merge or append.
Yeah,
something like this.
That's perfect. Yeah, I agree with Ahmad as well and Abdul. So like, you are not trying to find NA or whatever. You are trying to find, if you have two data frames, everything that is in this data frame is also in here. So you can use anti-join with that column that you want to. Yeah, this is perfect. I didn't even bring it on top of my head, but the discussion made it more clear. Right. So the last one, which is the factors and empty group. So let's look at it. So here we can see what they are saying is empty group. So what this is mean that if you look at this guy, we have names, right? And we have smoker and we have age. Now, definitely here, there is some kind of missingness because there should be like yes, if you want to try to do analysis or plot something, you will not see smoker yes, no, no yes, because there is no yes here. They are all no. So assume we want to count the number of smoker with the fly count. So when we run this guy, what we'll be seeing is only no is 5. There is no yes 0, right? So this means that we need to find a way to make sure that this doesn't count. And what this seed is, we can use drop equals to false. So using this guy, you can see drop equals to false. Then we have yes, 0. So this allow us to this allow us to see in a situation where you have empty groups. So you can see factors empty groups. So here this groups is empty, and in a way, if it is say it's empty, that group here, because we have only the yes is empty, there is no so we can use this drop in this case to show this. So this is all I got from the the session, but I'm not sure like if somebody can add on this, like why this drop.
I think they if you have multiple levels in a factor variable, and one of those levels are groups by like
it's factor. Yes.
So it's if you have a variable that sorry, a level that it doesn't have values, like contain values in the data set, so it doesn't show values for it in the tuple or in the data frame. You use this to show that this is an empty level. But this level exists, so you should take care that there is 0
okay.
Yeah.
So it's factor. It's factor. Yes. Okay. Oh yes. So this column is factor. Oh, okay. I see. Yeah. I missed this one. Okay. Yeah. So here, because I was wondering where this, yes comes from, because I only run this and the data set I didn't see. So I missed this one. Okay. Yeah. So this is useful for factors, only, I think, right? It's only for factors, right?
Yeah, exactly.
Okay, cool. So that's what I got. And today this chapter, as I said, is so small, and I think it really put some tools for us to detect any misness in the data, whether it is implicit, where it is explicit, and also even if it is factors and missing group, we can be able to do that. Okay. Anyone wants to add anything on top of this?
No, thanks. Thanks for your presentation. It was very, very quick and very concise. And
yeah,
it was very clear, by the way. So it's thank you.
Thank you very much, Ahmad. So next week, what do we got next week?
I think I will present, but I'm having like I have to present in the other club, the DevOps club. So next week, and I have a meeting before the club, so it's I don't know if I can, but I will I will say if I couldn't like present, go through the chapter together. So it's
yes, that's fine. Okay, yeah, that's fine. Okay, so after the join, we have another chapter spreadsheet. Oh, I don't know this one. Ahmad, you also sign up for the chapter, right?
Yeah.
Okay, the next one we have database. I sign up for the chapter. Oh, there is another one, arrow. I don't know what is arrow, but I will learn. I sign it. Then we have hierarchical data. Ahmad has signed. Then we have web scrapping. Abdul have signed functions. Okay, good. Right. Okay, thank you all for the discussion, and inshallah we see next week.
Inshallah.
Yes,
I'm just
yes.
wondering if you said that you have a presentation in a conference. Could you like send me a link? I'm very curious.
You say what?
You said that you presented in a conference or some type
Yes.
of thing. So
Yes.
could you like send me the link? I want to. I'm curious to see it.
Okay. Let me share it. Let me share it right now in my screen so that we can. Okay. Maybe you can ask question. So basically, what I'm working on is on NLP, and basically, let me share my screen again. We have a community for Africa researchers working on NLP. And what we did, basically, we developed Twitter sentiment corpus for African languages. And you can see we have like 14 African languages. So it's like a kind of collaborative work. And each country, because we have 14 languages, we have one person that lead, for example, getting the data and whatsoever. And that's why you can see we have many authors, some from, look at the countries. Is your country here? Egypt. Ahmad, you are from Egypt, right?
Yeah.
Okay, Egypt. Okay, so what we did basically is, we create this data, and on top of this, we wrote a lot of extensive, about the data set, some of the difficulty and whatsoever, and we, data annotation, and we annotated this data to sentiment, positive, negative, and neutral for sentiment classification, and we did a kind of experiment using pre-trained language model. Ahmad, you are working on NLP. Do you know pre-trained language model, right?
No, unfortunately, I'm not like working on NLP. But
okay.
I know that I did like sentiment analysis before, but didn't go deeper.
Okay. So we do some kind of machine learning classification, and this is it. So on top of this, we also share organize what is called shared task. We invited many people. We invited many people to come and participate in what is called competition. So for example, many teams around the world, from Germany, from China, from US, they participate in our share. So we organize this shared task, and you can see many teams, for example. So for example, you can see many teams participated in trying to solve the problem for, you can see Bosch. So these are the people that, participated, the, base system, Bosch Center for Artificial Intelligence, Harvard University, you can see many teams. So the essence of this is like a competition, like a Kaggle competition, but trying to solve sentiment analysis in African languages. So you can see like each language, for example, with that. And we also write, a paper describing the solutions, because for each participant, they submitted a paper, how they try to solve the problem and how their system solution is. And they submitted a paper, they will present the paper in the conference Canada. We have a conference in Canada, Samable. So this is paper that describe solutions with many system, many teams, how they solve the problem. So I'll share the paper with you. Yeah.
Wow, I'm just amazed. I think it's a very big collaborative work. I say.
Oh yes, yes. So what we are doing, what is lacking in Africa is, availability of data set to do even machine learning or NLP or any kind of machine learning. So our teams, our group, what we are doing is to come and collaborate and create this data set for African languages. So for example, you can see here, we have like Morocco, we have Algeria. So we have a data set in Arabic, Moroccan Arabic, which is called Darija. We also have Algerian people from Algeria, for example, Najma. So Najma is a postdoc at, University of Cambridge. So she works on Algerian Arabic. Umaima, she's from Morocco. She works on Moroccan Arabic. So like, for example, this Sayed, he's from Ethiopia, he works on, so it's just collaborative work. Yeah.
Awesome. Yeah, I would like read the paper and
Okay, I'll
really,
share with you. Yeah. Okay. I'll
Yeah,
share
it's
with
quite
you.
amazing. Quite amazing.
yeah,
You know?
fire life.
Okay, thank you very much. I'll share with the paper with you, Ahmad. Thank you.
Yeah, thanks.
Thank
Okay, see
Bye.
you next week. Bye.